Good afternoon. A very good day to all of you all. I'm Dr. J. Namrata Manohar. Come back with the episode 3 on tips to master computer programming. In my first episode, I had presented about 46 queries or questions which are to be solved if you want to expertise yourself in learning a programming language. In the episode 2, I had presented the preliminary terms of computer programming. This is in this episode 3 on tips to master computer programming. I am applying the first 20 queries to this C language with some program examples. So these are my previous videos which I had presented. First video was importance of programming for electrical engineers. Second, computer programming for beginners. Third, fundamental terms of computer programming. And fourth, make research thrilling. So this is my fifth video that I'll be presenting. Now here, as I told, we will be seeing the answers to the first 20 questions. Now, so preliminary information, set 1 questions as applied to C language. The first question was name of the language. The name of the language is C. It is not an abbreviated form. C is just the language name. Now, why it has come, we will see subsequently. Learn its correct pronunciation. C is pronounced as while we are learning the alphabets A, B, C. That is S-E-E, C. Now, study the history behind the name of the language. C is the successor of the programming language B. It has evolved from B. So C was originally developed at Bell Laboratories by Dennis Ritchie between 1972 and 1973 to develop kernel of the Unix operating system, which is a network operating system. But during 1980s, C gradually gained popularity because of its simplicity. Now, why is the language given that name? C was named so as it evolved from B language, which in turn evolved from BCPL, that is Basic Combined Programming Language. Now, who invented it? Ken Thompson and Dennis Ritchie. When and where it was invented? Bell Laboratories between 1972 and 73. But because of its simplicity and its middle-level language features, it has gained popularity in 1980. What is it mainly used for? That is, what is the area of application, whether it is used to develop front-end, back-end, or scientific applications or business applications. Now, C was mainly developed to write the Unix operating system, but later, due to its simplicity, it was introduced as a middle-level language and high-level language. Now, what is middle-level language? Why is it called middle-level language? Because using C, you can develop an operating system such as Unix, and using C, you can also develop your applications. Simple is, you want to process the marks of some students. Then you can use this C programming language. Or you want to use in your business applications, you want to compute the price of certain number of products and display how much of discount you want, you can use this C programming language. So it is suitable to develop both front-end, back-end, and system software. Now, what are this front-end, back-end, and system software? I've already explained in my second episode. So C can be used to develop front-end, back-end, and system software such as device drivers, compilers, and assemblers. It is widely used for network applications such as web servers and network protocols. What is the version of the language? The present version we are using is C17. C was standardized by ANSI, that is American National Standard Institution. Later, ISO also collaborated to standardize the version of C. Presently, the version is C17. Now, what are the hardware and software requirements for the language to operate? We are having The hardware required is you can have a desktop computer or a laptop computer with Linux operating system or Windows operating system or Turbo C. If you have Windows operating system, you can install Turbo C, which is a menu-driven software and easy to learn and use. Now, what are the important features of this C language? One is it is structured and procedural language. Structured because you have a specific format of the program, how it is to be written. So it is easy for you to learn, understand, and implement it. And it is a procedural language because once you have written the structure in a particular order, it is executed line by line in the same order. Fast and efficient. Because of its structured and procedural nature, the execution of the C program, development and execution is very fast and very efficient. Modularity. I had explained to you in the previous episode what is modularity. So using C, you can also develop different modules. Like you can have a file to enter the data. You can have another file to compute on the data, and a third file for only displaying your results. Or within one program, you can also have built-in functions. That is, say you want to find out the average, the maximum, the standard deviation you want to calculate of the data. You can write separate functions for each of them. Now, general purpose language. It is a general purpose language because you can use it for any application. You can use it in the school. You can use for business applications. You can use for scientific applications. It has rich built-in operators. There are various set of operators which we have already seen in the previous episode, right? The built-in set of operators are extensive, and so you can perform large number of operations. Now, built-in functions. The C has what is called as library functions, or another name in C, it is header files. So these built-in functions, there are some common functions like you want to find out the minimum, the maximum, sign, pause, and displaying your message, or you want to accept some data. So for all these functions, there is a standard computation. So all these have already, the functions have already been written and been stored in this built-in function, that is the header files. So by invoking the header files, you can use that particular function. Say the header file, one header file is stdio.h, that is standard input output.h. So here in this we have printf and scanf, that is to print your data and accept the data. These are the header files. So in this way, there are many files available. Now, is the language assembly language or high-level language? C is a middle-level language, but has the features of high-level language because it is easy for any person to learn the language and implement. Now, is the language compiler-based or interpreter-based? C is compiler-based. Is the language command-oriented or menu-driven? C editor as Turbo C is menu-driven. It is very easy to use. Now, it is a procedural language. C is a procedural language. Does the language support modularity, reusability, extendability, platform independence, and maintenance and security? Yes, it supports all these features, which we have already seen in this question number 10. Now, let us see some more. What are the list of commands for its usage? The list of commands normally will be based on the version and editor of that particular language you are using. But C, Turbo C is a menu driven. So by just clicking on the menu, you can use that particular option. Now, which editor does the language use? Presently, the most convenient one is Turbo C, though there are other software supporting C like Keel. Now, the program structure, the process of creating and executing the program, various files created during the process, we'll be seeing in the subsequent slides. First of all, let us see the editor, the Turbo C editor. As I told you, Turbo C editor is a menu-driven editor. So here you have what is called as a menu bar. In this menu bar, you have the various menu options, that is file, edit, search, run, compile, debug, project, options, window, and help. Again, with this, each you have sub-menu. That is file, you will have options for new, save, save as, etc. Edit, you can, if you have made any mistake in your program, you can use edit to cut, copy, and paste that particular option. Now, here we have search. You want to search for some product or you want to search for some word, you can use the search option. Then we have what is called as run. After compiling, normally after writing your program, you compile the program, and as we said, after compiling and rectifying all the errors, then you can run the program. Then debug. If there are any errors, you can use debug option. Then project. If there is a project wherein you have 2 or 3 files which are related to one particular activity, then you can store it in a project. Then you have some options, windows. You can see this editor window. You can see the output window by clicking on the various drop-down menu of window. Help, if you have any doubt in using any of the functions, built-in functions or any of these options, you can go to help and study that. Now, you have this close box. You click on this, it will close the box. You want to zoom it to full screen, you zoom box. Now, this is the cursor. That is where you're going to type your program. Normally, the cursor is starting from the top left corner. That's a good practice to start your programming from the top left corner. So once you start typing your program from this top left corner, that is first line, the first row, first column, and sequentially you type your program. Here, where the cursor is, it is displayed here. That is the line number and the column number where the cursor will be displayed here. This is called as the edit window. Then we also have what is called as shorthand options. We have what is called as shorthand options. This is the scroll bar. That is, you want to move up and down over your program, you can use the scroll bar. Then you have shorthand menu or keys. That is F1 for help, F2 for save, F3 for open, Alt F9 for compile, F9 for make, and F10 for menu. So this is the editor. So whenever you are learning any language, you should completely study which editor you're using and what are the various parts of the editor and what are the various options provided on the editor. Now, let us see the structure of the C programming. As we said, C is the structured language. So we have a program structure. Now, what are the parts of this program? Here we have what is called as the documentation section. In this documentation section, normally we give information such as name of the program, who has written, which date it was written, what is the purpose of the program. Now, how do you give this documentation section? This is a non-executable section. That is, the statements written in this documentation section are not executed. So how do you give it? How do you identify whether it is an executable statement or a non-executable statement? So these non-executable statements are all called as comment statements. C has 2 types of comment statements. One is single line comment statement and multi-line comment statement. Single line comment statement is given by this for 2 / lines. So here we have simple C program to add 2 numbers. So this is a single line comment statement. This line is not executed. It is only telling you that this program is used to add 2 numbers. Then you also have one more comment of provision, that is / and then star and /. This is anything written between these 2 are comment lines. So suppose your comments is extending to more than 1 line, you can use this multi-line comment symbols. Now, next is the processor pre-directive. As we have said that C is very strong with built-in functions. So these built-in functions are stored in libraries. So based on the function you are invoking, you should include that library in your program. Default, we use stdio.h because definitely we will be using printf and scanf and other input-output options. Then here we have the definition section. This is optional. Based on your requirement, you use it. Hash define max. That is, it is defining a variable max, the value 100. So if you are using the same value max 100 for more than one file, you can declare it outside the main. A void add and int x 100. These are all global declaration section. The previous episode I had explained to you about what is global declaration and global variables. Now, int main, this is where the execution starts. Normally in competitive exams or quizzes also, they will ask you what is the entry point of C programming language. Then you should say main. Main is the entry point. Now, main is a function. So, main also can take some arguments. Some arguments within this open and close brackets, we will see in subsequent episodes. Now, main is normally preceded by int or void. If you are writing int, then that means it should return some value. It should return some integer value. So, you have to give return 0. Or you can also keep this blank, which is void. Then you need not give this return 0. Now, main opens up with open flower bracket and close with close for bracket. So this is here, within this you write all your program, whatever you have written. So here I have declared a variable A of value 100. This is where you declare your variables. This is a print where I'm declaring hello main. So the output will be hello main. Then I can also have some functions, void add. You can write your function part here. Here I'm just showing how it is. This is your declaration section with the two comment statements. I'm invoking stdio.h plus the directive. I'm starting main with int, so I'm having return 0. Then since this program is to add two numbers, I need one number A, one number B, and the result of that I'm storing in sum. You can use any variable x, y, z also. You can use x, y total you can use. So initializing sum to 0. This is a good practice to initialize the resultant to 0. Because suppose sometimes the same variable was used another file, then whatever value was there in that variable, it may be carried over here. So it's always good to initialize your resultant to 0 initially. Since it is integer, I'm initializing it to 0. Now, here I want two values. I want to take it, use the program to compute any value of A and B. So that's why I'm displaying printf, enter the value of A. So this is the syntax of printf statements. What is the syntax of printf statements? Within quotes, you are using the user-defined image. So anything that you give between these two quotes, it will be displayed out. And every statement in C is terminated by a semicolon. Every statement should be terminated by a semicolon. Now, scanf %d ampersand A. So I'm telling enter the value of A, but I have to accept the value of A and store it in the variable A. So what is the format of scanf? Scanf format specifiers within quotes ampersand value 1, ampersand value 2. If you are giving only one variable here, use only one ampersand value 1. Like here, I'm giving scanf %d ampersand A. Similarly, printf, enter the value of B, scanf %d ampersand B. Now I'm going to compute the sum of A and B. So I'll write the arithmetic statement, sum is equal to A plus B. Now, printf. Sum of A and B is equal to %d sum. So whatever %d I'm giving here, it's a variable of type integer. This is format specifier. So that variable I have to mention here sum and return 0 and close your main program. This is the C language structure. So based upon your logic, you write all the programs within this open and close brackets. Now, what are the various format specifiers provided? Let us see. Format specifiers are %C, that is for single character. And every specifier, every data type occupies some memory space. So here, this data type has a size 1 byte. Integer is %d, it occupies 2 bytes. Float %f, it occupies 4 bytes. Double, it is double of float, lf, it occupies 8 bytes. Unsigned int, %u, 2. Unsigned int means you can accept positive and negative values for this integer. Then you have long int, which is of 4 bytes, and long double, which is of 10 bytes. So based upon the size of the data, what type of data you are entering, you should declare the variables. Let us see the applications of these format specifiers for a simple circuit. Here I have 3 resistors, R1, R2, and R3. R2 and R3 are parallel, and again, these 2 parallel resistors are in series with R1. They are connected to voltage V. So the question says, write a program to determine the current in the circuit as shown in the figure. Given that R1 is 6 ohms, R2 and R3 are 2 ohms, and the voltage is 12 ohms, 14 ohms. So I'm going to write the program for this. First, I need to compute the equivalent resistance of these 2 parallel resistors. And then I need to add it to R1 to get the total resistance of the circuit. Then I'll divide the voltage by the resistance to get the current. That is the normal formula. So before starting writing any program, you should know what is the logic of the program. How are you going to compute? Say you want to compute the percentage. You should know what is the formula you will be using and what is the data you are entering. So the program, you need to know what data you are entering, what is the logic of computations. So the program name I'm here giving, this is the documentation section given by /* and //. The name of the program is current1.c. That means when I say file save, I'll be storing with current1.c name. Now, this is the header file I've invoked, stdio.h. This is the main starting. Now, here again, you can use comment statements anywhere in the program, right? So it explains the subsequent line to explain your subsequent line. So now I'm declaring variables for 3 resistances and an equivalent resistance and voltage and current. So appropriate names you should show. Actually, you can use any variable name, but appropriate names you should use. So when you see the name, you'll be able to understand what you're storing in that variable. So here I have int R1, R2, R3 and voltage. Now, current is a float. I'm taking current as floating value because once you divide 2 numbers, you may get a float value. Then I'm also having equivalent resistance. I'm also having the variable equivalent resistance. Now, equivalent resistance, again, as I told you, I'm initializing it to 0.0 because it is float, it has a decimal component. Now, R1 is already given the value 6. So I'm saying R1 is equal to 6. R2 and R3, here, this is a term, I'm using this colon. So because I have this less screen space, I'm closing this with a semicolon. R2 is equal to R3 is equal to 2. Close this statement. Then voltage is equal to 14, already given in the question. Close the statement. Now, what I'm going to do subsequently, compute the equivalent resistance of R2 and R3. So, R2 EQRES is equal to R2 into R3 divided by R2 plus R3. This is the formula we should use when 2 resistors are in parallel. Now, after computing the equivalent resistance of R2 and R3, I have to add it to R1 to get the total resistance. So what is the total resistance? EQRES is equal to EQRES plus R1. Now, C provides what is called as shorthand operators. That is, EQRES is equal to EQRES plus R1 can be written as plus is equal to R1. So EQRES plus is equal to R1 means EQRES is equal to EQRES plus R1. These shorthand operators, if you are using, they will know how skillful you are in the C programming language. So what are the advanced features of the language you should know and try to implement in your programming. So they will know to what extent you have expertise in that particular language. Now current in the circuit is voltage divided by the equivalent resistance. So current is equal to voltage by equivalent resistance. Now I need to finally print the resultant current in the circuit. So printf current in the circuit is equal to percentage F, because current is a floating value. So I'm using percentage F format specifier. A means amperes. So current. So when I execute this program, compile, remove any errors that I debug it, and on execution, I will get the current in the circuit is 2 amps. So once you get the result, you have to check whether you're right or wrong. Now, when R2 and R3 are in parallel, the result is 1 ohm. You're adding this 1 ohm to 6. So 6 plus 1, 7. So 14 divided by 7, what you get? 2. So current in the circuit will be 2 amperes. So normally the display will be 2.0. Right? Now, what is the process of creating and executing the C program? You have written the program, but now what is happening to the program? How we are getting your output? What are the various files created during the creation and execution of the file? So this is the process of creating and executing the program. So editing, first and foremost, you are opening the editor and you're typing your program on the editor. So here you will click on File, New. When you click on File, New, then the cursor goes to the first row, first column. So wherein you can start writing your program. So once you write the program, this is the same program we have just now discussed, program to add 2 numbers. So you start writing from this point till the last value. Now I have given it main as int, so that's why I've written here return 0. So once you type your entire program, right, then what, and you're going to compile the program. You're going to click on the compile option in the editor. Then what is there? Once you edit the program, the source file is called .c. Every file has an extension. So here, since it's the C programming language, the extension is .c. So what is my star? Sum1.c. So once you have edited the program, you are going to compile. When you compile, you will get what is called as an object file with the extension .obj. Now, if there are any errors, right, then you have to go back and then go to the editor and make the corrections. If there are no mistakes, then you go into it goes to the linking section. That is, in this link section, it links your program to the header files that you have invoked. That is the library files. Here I have invoked stdio.h. So this print and scanf will be linked to this stdio.h. Right? Now, after linking, if there are errors, again, you go back to the error editor and make the corrections. If there are no errors, then finally the .exe file is created. So once the .exe file is created, you can execute the program by clicking on the run option in the menu. And then again, in the run option, if there are any errors, say there is a mismatch of the data type or so, then you have to go back to the editor and then make the corrections. Otherwise, you will be getting your final result on the screen. So here, this is the program, what we have done. So the program here I created is sum1.c. So on compiling, we get the object function sum1.obj. Then the final executed file is sum1.exe. Now, what is the input you will get here? I am getting enter the value of A. So it says enter the value of A, 6. Now, enter the value of B, 8. I have entered these two values. So what is the sum of A and B? What I have given here? Sum of A and B is equal to percentage D. So in place of percentage D, it will be printing the value of this sum. So I'm getting sum of A and B is equal to 14. So this is the final output which we'll be getting. Now here we have what is called a /n. /n is called as a new line character. That is, here I am displaying enter the value of A. Once this is displayed, the next cursor goes to the next line. If you don't give the /n, what happens is you have to enter your value here 6 only. And what is the next print statement? Enter the value of B. Again, it goes into the same line. So in the output screen, everything will be seen as same line. You will be confused. So to get this exclusively like that in separate lines, to the extent possible, we use /n at the end of every print statement. So your programming output will look neat. You will be able to understand. The person who is using the program will be able to understand, and you will be getting the output proper. So this is the first 20 questions which we had discussed in our episode 1. So any doubts, please you may contact me on my mail ID jnm7064@gmail.com. Please do not forget to share and like and subscribe to my channel. Thank you.